basic trig ratio functions that we have talked about in geometry before are what? Who remembers what a trig function is? Cosine? Yeah, SOHCAHTOA is like how to remember what the ratios are, but your actual trig functions are sine, cosine, and tangent. Now, on your calculator, these three things show up as not sine with an E at the end of it, but it shows up on the calculator as sin. But I don't want you to say sin. It's actually sine, okay? So that shows up as sine, S-I-N, and then cosine is C-O-S, and tangent shows up as T-A-N. Yes? Okay. Those are the regular trig ratios that we know. Okay, there are other ratios of trig functions. It's the reciprocal of them. So basically it's like the opposite, which I don't want you to confuse with the inverse. So above the calculator button sign, do you guys see the sign with the -1 there? Okay, that inverse function of sine allows you to solve for angle measures. Okay, taking the inverse sine of our ratio of like opposite over hypotenuse allows us to find the angle measure. Okay, this is just another trig ratio that you've seen on some of like the ECT practice and stuff where it says like cosecant or CSC. You don't know what that means, but it's one of these, but it's just flipped over. Okay, so the reciprocal, oops, let's change the color here. Your reciprocal, oh no. Your reciprocal functions are going to be cosecant, secant, and cotangent. And I wrote them in that order specifically because sine and cosecant are related because one of them is just flipped over. Like your fraction that you normally do SOHCAHTOA, like opposite over hypotenuse, is the opposite. So it'd be hypotenuse over opposite for the side length. Okay. On your calculator, actually, I still haven't found, I don't know if there's a button on your calculator that allows you to do this. So technically, this is the same thing on your calculator, would be as 1 over sine to find cosecant. To find secant, it would be 1 over cosine of whatever you're finding, and cotangent would be 1 over tangent. Okay. Now, the abbreviations that you might see for these are CSC for cosecant, SEC for secant, and COT for cotangent. Okay, these really aren't going to show up today, but I just want a quick little preview for you guys to see, like, these other trig functions do exist, okay? All right, let's draw a little picture of a right triangle here. Okay. Oh, it's kind of tilted there. That's good enough. So my right triangle, always denoted with a little right angle on the bottom there. Okay. Let's say that this is side length A. From side length A, I want to label my adjacent, my opposite, and my hypotenuse. Go ahead and take 5 seconds. Try and label what those three parts are going to be on your triangle. Hopefully you remember from geometry. If not, I'll write them up here in a second. That's okay. So label your hypotenuse, adjacent, and opposite side length on your triangle. Do we all agree? Okay. Hypotenuse is always the longest leg of your triangle. Okay, so someone said at the very beginning, SOHCAHTOA. Okay, this helps us remember what our ratio is going to be for each of those trig functions, right? The S stands for sine. So sine of A would be opposite over hypotenuse. Okay, if I was finding the cosecant of A, that's just 1 over the sine of A. So basically all that means is you're going to flip-flop. It's going to be the hypotenuse over your opposite side length. Okay, cosine. What does the A and the H stand for in cosine? Yeah, adjacent over hypotenuse. And again, if I was finding the secant, it's technically the hypotenuse over the adjacent. You flip it. And then T stands for tangent. And the O and A stand for opposite over adjacent. Okay, so hopefully you remember when we're solving these things, this big A is an angle, okay? The A is an angle. This stuff, this ratio are the side lengths, okay? So if we're solving for A, how do I undo the sine or the cosine or the tangent? How do I get rid of that 3 letters in front? What do I have to do? Like, for example, if I gave you something like the sine of A equals 3/5, how would I solve that?
Get rid of the sine.
Yeah, but can I just like divide by sine?
You multiply by 5. Right?
Not multiply by 5. Because I can't just divide by sine. This is like a number. Sine of something is going to give you a number on your calculator. So to undo the sine, there's a button right above it. Sine inverse. If you did the sine inverse of both sides, that's going to go away. And then you're left with the inverse of 3/5. Okay, now I totally just came up with a random thing there. So I have no idea what the answer is actually, but if you plug that in on your calculator, you're going to get one of 2 answers. You're either going to get this, or you're going to get this. How do I get 2 answers? Well, first of all, did anyone get both of those answers or one of those answers at least? Confirmation on both, maybe? Yeah.
I got the right one.
Which one's the right one?
Well, I actually don't know. Hopefully it's 36.
36? Well, technically they're both right. One of them is in a certain mode and the other one is in a different mode. What would this first one be in? What mode would that be in? This is in radians, okay? And this one is in degrees. So I didn't specify technically, okay, so you wouldn't really know. But on the problems that we're going to do today, we want to be in degree mode, okay? So on your calculator, if you hit mode, you want to make sure that degree is selected. And if it's not, you'll have to move down to select it and hit enter and make sure that it is selected, okay? After we take this quiz, okay, then it's going to get kind of tricky to remember when am I going to need to be in radians, when am I going to need to be in degrees, okay? If you're given something in terms of pi, you're probably using radians, okay? If you're given a degree, you need to be in degrees. So just be careful moving forward that you know which mode you are in, okay? Any questions on just like the basic trig stuff there? Does that make sense? Did we like hopefully remember this a little bit, the sine inverse, to get rid of the sine? Yeah, a little bit? Okay, good. I'm glad it's coming back a little. Okay, moving on here. So these application problems, on your quiz, you will have to draw the picture yourself. Okay, these first 2 we're just actually gonna just solve, but then we're gonna have a few word problems, and the only thing that makes it really a word problem is the words elevation and depression. Okay, so if I'm looking straight and I have an angle of elevation that I'm looking at, do you think I'm gonna be looking up or am I gonna be looking down? I'm going to be looking up, okay, looking up at the sky. Now, if it's an angle of depression, think about like you're a plane, okay, and I'm looking down at the earth, okay, that would be an angle of depression, okay, to the earth. So, but let's just start out with some some just basic problems here. Okay, it says solve each right triangle with A being 34 degrees and 30 minutes, that notation, and C is 12.7 inches. Be careful with units here. If you're solving for a side length, I should have some sort of units with it unless it wasn't given to you, okay? If I'm solving for an angle, make sure you have a degree symbol there, or if it's in radians, you have it in radians. But all of today and all of your quiz will be in degrees, okay? So if I want to solve this, I would say first thing that we want to do is find out what is this in just degrees. We don't want to mess with the degrees, minutes, seconds. We don't need to. In this case, let's just get it in terms of degrees as a decimal. Okay. So in order to get there, if you remember, you hit second apps to get to the angle function, and that allows you to choose the degree and the minutes button. Or if you remember, how many minutes are in a degree? 60 minutes are in a degree. So if I have 30 minutes, how much of a degree is that? Yeah, 0.5, right? So this is equal to 34.5 degrees. Are we okay with that? Okay. So this is 34.5 degrees. And I know angle C is 90 degrees because it's marked on there. Could I find out angle B pretty easily? Yeah. Angle B is just going to be 180 minus 90 minus 34.5. So your measurement of angle B is equal to 55.5 degrees. Notice how I had the degree symbol there, so that way we know what did we just find. Okay, now I need to find A and B. So in order to find A and B, we need to use a trig function. Okay, since we were given letter A, I'm just going to go from letter A. So letter A, I know to find the small letter a, or the lowercase, I need to use what trig function that relates this side length and the 12.7. What relates those two? Sine, cosine, tangent. Sine. I know this is the opposite, and this is the hypotenuse. Okay, so I'm going to do the sine of 34.5 is equal to A divided by 12.7. Okay, are we okay with that setup? Okay, now from here it just becomes an algebra problem. How do I solve for A? Yeah, multiply by 12.7. So A is going to equal 12.7 times sine of 34.5. Okay. Now, I want everyone to plug this in the calculator to make sure we are in the correct mode. But when you plug it in, you should get 7.193 inches. Okay, let's just get in the habit of trying to round to 3 decimal places if possible. Just so that way we're staying consistent. And 3 is usually a good kind of rule of thumb there. Okay, so plug that in your calculator. Double check that you get the same answer as I did. Okay, so now that we know A, I'm going to solve for B, okay? Now, I usually just use the angle that I'm given, but could I technically use this 55.5 as well? Yeah. Yes, I totally could. But let's just stay consistent. I'm going to use that angle A again, 34.5. How is B and the 12.7 related? Is it opposite, adjacent? What is it? It's adjacent over hypotenuse, which means I'm going to use what trig function? Cosine, okay? So I'm going to do cosine of 34.5 is equal to B over 12.7. Same thing, cross multiply here. And I get that B is equal to 12.7 times cosine of 34.5. And if you plug that into your calculator, we should get 10.466 inches. All right, let's look at the next one because we got all those 3 things. Next one, we've got A is 29.43, C is 53.58, and we need to find the side length B, the angle B, and the angle A. Okay, let's start with the side length of B, because what are we going to have to use here? If I know 2 side lengths of my triangle, we're going to have to do Pythagorean theorem. If you forgot what it is, I'll write it up here. A squared, B squared equals C squared. So we've got 29.43 squared plus my side of B squared is equal to 53.58 squared. Just a little bit of an algebra problem here. Subtract that over and take the square root. Plug that in your calculator and double check that you get 44.774 centimeters. All right, now I want to solve for the angle measures. Okay. Again, I like to just use what we're given. That way it's not like an approximate value, okay? We're given these two side lengths. So if I wanted to solve for letter A, and I know this side and my hypotenuse, what trig function am I going to use? Sine, right? Because this from letter A is the opposite over the hypotenuse. Okay, always opposite. And my hypotenuse is always the longest side. So if I did sine of A, that's going to equal 29.43 divided by 53.58. Okay, I can't just divide by sine, okay? It's a function. It's a ratio of these two side lengths. So right above sine on your calculator is the sine inverse button. That's the inverse of sine. Just like addition is the inverse of subtraction, subtraction is the inverse of addition. We have to do the inverse operation to get rid of that function. So I'm going to take the sine inverse, technically of both sides, for those to go away. And if you plug that into your calculator, that's going to give you an angle measure, okay? So the measurement of angle A is going to be approximately 33.317 degrees. Anyone not get that on their calculator? All right, and then just like Will was saying here, if I know now that this angle is 33.317 degrees, and I know this is 90 degrees, do I need to do another trig function and inverse to find out what letter B is? No, I can just find letter B by subtracting, okay? So if you did 90 minus, technically it's 180 minus the 90 minus my 33.317. For my measurement of angle B, I get approximately 56.683 degrees. Okay, and depending on how much you round, you might be off by a little bit there, but somewhere close to that. Now, you could have also started by finding letter B and using these two side lengths. If I was finding to start with letter B, I would know this is my adjacent and my hypotenuse. So what trig function would I use if it's adjacent and hypotenuse? Cosine, right? So I would do cosine of B is equal to this number over that number to find out letter B, okay? Moving on to angle of elevation and depression, which is just one other word that we got to remember. What does it mean? So I'm just going to draw a quick little picture here. For angle of elevation, that would mean I have, like, if this is my line of view, this is where I'm looking, this is my line of sight. Okay, angle of elevation would be that angle looking from where you're looking and then up. Okay? Or it could, be the opposite way. It could be like this. I could be looking up that way. And then angle of depression, if this is my line of view, my angle of depression is going to be just this angle from your sight all the way down, or vice versa, just in the opposite direction there. Most of the time it's going to be like looking up at a tree, looking up at the sun, or looking down from a building, or looking down from a plane. Those kind of things. So those will use like find the elevation to the sun, find the angle of depression from the plane. You'll have to be able to figure out what angle is it talking about. Okay? Again, on your quiz, you will have to draw these pictures yourself. But if we read this question, hopefully we can see where this picture came from. It says the length of the shadow of a building, 39.09 meters tall, is 37.62 meters. It's kind of worded a little funny, but this is how tall the building is. Sorry, this one right here. This one right here. What? That one right there is how tall the building is. And then your, no, sorry, I said that wrong. This is how tall the building is, and this is your shadow. Your shadow is the 37.62. So got my building here, got my shadow on the ground, my sun's up there. It says to find the angle of elevation, okay? So angle of elevation that we're finding is going to be this angle right there. I want to figure out what is angle B on this picture. So from angle B, I'm given two side lengths. What two side lengths am I given in terms of opposite, hypotenuse, and adjacent? Yeah, I'm given the opposite, and I'm given the adjacent. So what trig function am I going to use to find B? Tangent. So tangent of B is equal to 34.09 over 37.62. And again, if I want to get rid of this tangent, I need to take the inverse of both sides. So B is actually going to equal the inverse tangent of 34.09 divided by 37.62, which approximately will give you on your calculator, double check, should be 42.182 approximately. So that is my angle of elevation.
What's the squiggly equal sign mean?
Approximately.
Oh.
Yep, the squiggly sign. Yep, approximate. There probably, if you're on paper, there's probably not a ton of space to do this problem. But if you're on your iPad, you'll want to make sure you're zooming in and stuff because it kind of does take a little bit of space for this one, okay? So the picture is drawn for us already. It says Francisco needs to know the height of the tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7. So that's this first little triangle here. And then it says he moves back 50 feet. From that second point, there's an angle of elevation, and that is 22.2. So find the height of the tree. Okay, so I'm going to draw both of these triangles out separately. So I've got this big triangle, and that big triangle has a side length here of h, and this is 22.2. And what would this long side be on the bottom there? Yeah, 50 feet plus x, right? Or I'm just going to label it as x plus 50. Okay, then I've got another triangle here. This is h. This is just x. And this is 36.7 degrees. Okay, we can assume that this is a right triangle for all these problems here. You can assume that that will be a right triangle. So now, are these triangles like similar or congruent by any means? No, so I can't set up any proportions or anything, but could I set up a trig function using this angle and this angle to relate the side lengths of h and x plus 50 and h and x? Yeah, like what trig function is the opposite over the adjacent side? Tangent, right? So let's go ahead and write both of these trig ratios out first, and then we'll see what kind of happens here, what kind of algebra happens. So I've got the tangent of 22.2 is going to equal h over x plus 50. I've got two unknowns. Okay, the triangle that I drew over there in red is going to be tangent of 36.7, and that's going to equal h over x. Are we okay with the setup here? So I've got two unknowns, I've got two equations. I'm going to have to do some sort of algebra here. The easiest option here, and I think maybe the only option, is going to be to do substitution. Okay? So let's get rid of these fractions here. Let's cross multiply and get rid of those fractions. So I'm going to take and multiply x plus 50 on the left times tangent of 22.2, and that's going to equal h. Now, I'm missing something up there. What do I need on the left side? Technically, that says x plus 50 times tangent of 22.2. Is that what I want it to say? No, I want it to be the entire quantity of x plus 50, right, times both sides. So I got to have parentheses around that. Got rid of my fractions. Okay, let's do the same thing for my red one here. So I've got x times tangent of 36.7 is equal to h. Well, if this is equal to h, could I plug it in here? Ah, yes I can. So let's go ahead and do that. I've got x plus 50 tangent of 22.2 is going to equal x times tangent of 36.7. And I can plug it in because h is the same thing for both of these ratios, right? Same thing for x too. But now what are we going to have to do? What kind of algebra am I going to have to do in order to solve this? Can I just go like this? No. Tangent of something is going to give you a number. So I can't just cross out the tangents. Okay, but I have an x over here and I've got an x over here. I want to get all my x's together, but I've got this little set of parentheses here going on. So let's distribute this tangent of 22.2 to both x and 50. Okay? Again, tangent of 22.2 is really just a number. Think about it being like 5. Distribute the 5 to both of those things. Okay, so let's distribute that. I've got x times the tangent of 22.2 plus 50 tangent of 22.2. And that equals x tangent of 36.7. Okay, now how do I get all my x's on one side? What would you guys do?
Subtract the x from the 22.2 term.
Yeah, we're going to subtract this one over to the other side. Okay, so let's subtract x tangent 22.2, subtract x tangent 22.2, that goes away. Now I'm left with 50 tangent of 22.2 is equal to these two things subtracted from each other. However, could I take an x out of both of those? Yeah, so that I can actually solve for x, right? So let's take an x out. I've got x times tangent of 36.7 minus tangent of 22.2. I just factored out the x so that I can get x by itself. Because now I have x times, again, this here is just going to be a number. If you plug that in the calculator, it's just a number. So now if I want to get x by itself, what do I do? Divide by all that stuff in parentheses. Okay, so I'm going to divide by tangent 36.7 minus tangent 22.2. That goes away. And now on your calculator, very carefully, I would make sure you type it in as a fraction. And be careful because when you type like tangent, it populates one parentheses, but it doesn't populate that second one. So make sure you end that parentheses before you type the next thing, okay? So type this in your calculator, double check that you are all going to get the same answer of 60.497. And my units for that length is in feet. So this is my answer in terms of feet. So take a minute, plug this in your calculator, double check that you got the same answer. Okay, now did we actually answer the question? Let's go back and look. Okay, it says find the height of the tree. We found x. X is just the distance, right, between that first spot where he was looking up and the base of the tree. If I want to find h, what am I going to have to do? Just one step. We just got to plug it in, right? Don't we have a formula for what h equals? We have actually two of them, don't we? I would say we use the one over on the right side, though, because there's one less thing that we have to plug in. So I can just take this and plug in my x, which was 60.497, and times that by the tangent of 36.7. And when I plug that into my calculator, double check, but you should approximately get 45.09 feet. And this right here is your final answer. There will be a question like this on your quiz, just one of them, and there will be a question like this on the review. This one is tricky, but all you got to do is set up your two equations and then solve for one of your variables so that you can solve and plug it back in. Okay. Any questions on this one? I know it's kind of tricky, but yeah.
I got a different answer when I put in the fraction.
The fraction, let me